Back in 2017, a team at Google dropped a paper with a kind of quirky title that would, no exaggeration, completely change the future of AI. This is the story of that paper, Attention is All You Need, and how the architecture it introduced laid the groundwork for pretty much all the AI we use today. So, let's get into it and break down what made this thing so incredibly revolutionary.
It's a really good question, right? How does a machine actually get the context and the little nuances in language? How does it know that a word at the beginning of a sentence connects to one way at the end? Well, the answer comes from completely rethinking how we teach machines to read in the first place. So before this paper came along, the biggest roadblock in AI language was what you could call the problem of sequence. It's all about how you process information that comes in a specific order, like words in a sentence, but still manage to understand the bigger picture.
For a long time, the best AI models, called recurrent neural networks, or RNNs, read pretty much like we do, one word at a time, from left to right. And it makes sense, right? You read the first word, then the second, and you carry the meaning along as you go. It's a step-by-step sequential process. But that step-by-step approach had some major issues. First off, it was slow. You couldn't really speed it up because you had to go in order. But the bigger issue was a memory problem. Think about it. By the time the model got to the end of a long paragraph, it often kind of forgot what was said at the beginning. This made understanding the full context, connecting ideas that were far apart, almost impossible.
And this really shows you the leap in thinking. With the old RNN models, the path between the first word and the last word was really long. The longer the sentence, the longer the journey for the information. But the transformer, it created a direct connection. Any word could talk to any other word instantly. The number of steps is always just one. That, right there, was the absolute game changer. So, the stage was set for a truly radical idea. What if you could just get rid of that slow, sequential process altogether?
I mean, this one sentence from the paper's introduction was a bomb. The authors proposed a new architecture called the transformer, and it completely threw out the old rulebook. Instead of going word by word, it was based entirely on a concept they called attention.
So what is this self-attention thing? Well, it's a super clever way for the model to look at all the words in a sentence at the exact same time. It then figures out how important each word is to every other word. This is how it can understand that in a sentence like, the robot picked up the ball because it was heavy, the word it is talking about the ball, not the robot. I love this analogy because it's so perfect. The old models were basically reading a sentence through a tiny straw, only seeing one word at a time. The transformer, with self-attention, could see the whole page at once. It could grasp the full context in a single moment.
Okay, so how does this new architecture actually work? Let's pop the hood and take a look inside the transformer.
All right, so this is the diagram from the original paper. I know, it looks a little intense. But don't worry, the main idea is actually a pretty simple two-part process. The stuff on the left, the encoder, its job is to read and understand the input text, say a sentence in English. Then, the part on the right, the decoder, uses that understanding to generate the output, like the French translation. And the real magic is that both sides are built out of these powerful new attention layers. But wait a second. If the model sees all the words at once, how does it know the original order? Well, that's where a really clever trick called positional encodings comes in. It basically gives each word a unique timestamp or a digital address, so the model knows that the cat came before sat on the mat. And the real engine driving all of this is something called multi-head attention. Think of it like giving the AI multiple sets of eyes to look at the sentence from different angles. So instead of just trying to find connections between words one time, multi-head attention does it several times, all in parallel. It's kind of like having a team of different experts, all looking at the same sentence. One expert might be focused on grammar, another might be tracking the who did what to whom, and a third might be looking at the overall sentiment. The transformer does all of this at the same time. So, in practice, what happens is the model splits its focus. One of its attention heads might be laser-focused on tracking the subject and the verb. At the exact same time, another head is figuring out which pronouns refer to which nouns. Then it combines all these different points of view. And the result? A much, much deeper and more layered understanding of what the sentence actually means. So all of this sounds incredible in theory, right? But did it actually work? Well, the results were nothing short of a massive breakthrough. The team tested the transformer on machine translation, and they measured its quality using something called a BLEU score. You can just think of it like a grade for the translation. The higher, the better. At the time, The very best models in the world were scoring around 26.3. The transformer, on its first real test, scored a 28.4. Now, I know a jump of about 2 blue points might not sound like a lot, but trust me, in the world of machine translation, that is a gigantic leap. The transformer didn't just barely beat the old record, it completely shattered it. And it did it with a single, much cleaner model.
And here's the other wild part. It was way more efficient. Because this whole attention mechanism could be run on tons of computer chips at once, parallelized, the transformer could be trained in just a fraction of the time. So it wasn't just better, it was also faster. That's the dream, right?
And this wasn't just some one-trick pony that was good at translation. The team also used the transformer for a totally different, really hard task, basically teaching a computer how to diagram a sentence to understand its grammar. And guess what? It excelled there too, proving this new architecture was incredibly powerful and versatile.
So, what's the ultimate legacy of this paper? Honestly, it goes so much further than just making better Google Translate.
This single idea, swapping slow, sequential processing for massively parallel attention, became the blueprint for almost all modern AI. You know, the T in ChatGPT or GPT-4? Yep, that stands for transformer. This paper provided the fundamental architecture that's enabled this incredible AI explosion that we're all seeing today.
The transformer gave AI a way to see the whole page at once. It was a brand new way to understand context. Which leaves us with a really exciting question for today. What's the next fundamental breakthrough going to be? What will be the next leap that teaches AI to see and reason and create in ways we can't even imagine yet?